In today's lesson, we will learn how to factor a polynomial with a common factor, how to factor a polynomial with a common binomial factor, and how to factor a polynomial by grouping. So 3 different types, and we'll go through them. But first, you probably are very good at expanding. You've been practicing this. So if I were to ask you to expand 5 bracket x plus 3, you will be able to do it probably with no difficulty, and it would be 5x plus 15. Well, what about if I ask you to work backwards? What about if I were giving you the final answer first, and then you have to work backwards? So 7x plus 29. What would be the original question? Okay, so again, hopefully most of you would have guessed that the original answer was 7x plus 3. Okay, so let's try one more. What about if I were to give you 9x minus 54? What would be the original answer? So some of you would have written 9x minus 6, and that would be correct. But some of you could have written as 3x minus 18. And if I were to expand it back, I will get this expression. Both of the answers are correct, but we would like to always factor the greatest common factor at the front. So this is the format that we would prefer, with the greatest common factor outside the bracket. All right, so hopefully you're kind of understanding it right now, that factoring is opposite of expanding. All right, so let's try to factor this expression, 4x cubed plus 2x squared minus 8x. All right, so I'm going to do this question 2 different ways. One will be a longer way, which will kind of explain the thought process that should be happening in your head. And the other one will be a little bit faster that you might be able to do once you've practiced this way. All right, so the first way to do it is basically apply all the prime factorization to 4. So the 4 will be written as, well, first of all, we know that we will have 3 terms here. So I can kind of write them here, and I know that I will have 3 terms in this expression. There are 1, 2, 3. So the first one, 2, can be written as a product of prime factors, which is 2 times 2. Then I will look at x. Again, I can write it as a product of smaller factors, so x times x times x. And then I'm going to look at the second term. Second term could be written as 2, just times 1, we don't write 1, and then it will be written as x times x for this variable. And the last term will be 8 is 8, so prime factors will be 2 times 2 is 4 times 2 is 8, and then only x once. And the next step will be to find the greatest common factor. So what's in common to all these terms is we have 2 here, and a 2 here, and another 2 here. So those 2's are in common. Let's see if I have another common factor. I have a 2 here, but I do not have a 2 over here. So therefore, for a coefficient, 2 is the greatest common factor. Then I'm going to look at my variables. I have x here in common, and so is here, and here. All right, and then I'm going to look for maybe another one, but I can see that there's no more variables here, so this is it. So that it looks that 2x is the greatest common factor. And then, of course, I will write my bracket. Oops, sorry. I'll change the pen. will write my bracket here. And again, I know I have 3 terms in my original expression. So I will still have 3 terms in my bracket. Oops. All right, so then I'm going to, since I factor 2x outside the bracket, I will just write what's left over. What I have left over is 2x and x over here. Over here, in this term, I have only x left over. And over here, I have 2 times 2 that is left over. All right, so then I'm going to kind of simplify it, clean it, and the final answer will be 2x squared, x times x, plus x minus 4. And this expression now is written in a factor form. We're having 2x as the greatest common factor. If I want to make sure I did it correctly, I will expand it and see if I'm getting the same answers. 2 times 2 is 4. X times x squared, I apply exponent laws, we'll have an x cubed. 2 times 1 is 2. X times x is x squared. 2 times negative 4 is negative 8. And then x times, many times we don't write this 1 here, but there would be a 1 here, times 1, and I will just have x. All right, so that's one way of doing it. Another way of doing this question is a little bit faster after you've practiced all the work before. Basically, what you're going to do is you will look at these 3 terms, and then first you will find the greatest common factor for 4, 2, and 8. So with enough practice, it's probably very easy for you to say that 2 is the greatest common factor for the coefficient. And then you will look at the variables. And I only have one type of variable, x, and you will then check the exponents. This is to the power of 3, this is to the power of 2, and this is to the power of 1. And then I will find the exponent, the lowest exponent, variable with the lowest exponent, which is x to the power of 1. And that is going to be my greatest common factor with respect to x. So I will say x is the greatest common factor there. And then I will open the bracket. And again, I know I'm supposed to have 3 terms, and how I will get them is basically I will take the original term and I will divide it by my greatest common factor. So 4 divided by 2 is 2. X cubed divided by x, applying exponent laws, will give me x squared. 2 divided by 2 is 1. X squared divided by x is x. Negative 8 divided by 2 is negative 4. And x divided by x is 1. So I could write times 1 here. And very quickly, I will clean this up and say 2x squared plus x minus 4. And I got the same answer, exactly the same answer as in a previous method. All right, so that's maybe a shorter, faster way of doing this question. So anyway, why don't you try one question on your own? So this is a good time to pause the video, try it, and then restart your video to compare your answer. All right, so in this question, I'm going to do this question 2 different ways again. So the first one is, of course, I'm going to write a big bracket here. And I know I have 3 terms, so I'll put minus here and a plus here. And then I'm going to write it, apply prime factorization. So 8 is 2 times 2 times 2. And then x cubed, written as a product of smaller factors, will be x times x times x. The second one will be 2 times 3, and then will be x times x times y times y. Sorry, I need to squeeze that in. And the last one will be 2 times 2 times x, and times y. All right, it's a long process, but sometimes we have to do it this way to fully, clearly see what factoring is all about. So now I'm going to find the greatest common factor. So 2 is here, 2 is here, and 2 is here. Then I'm going to find another common factor for the coefficients. I have 2 here, I have 3 here, and they're not in common. Therefore, I will have to, that's not the common factor. So then I'm going to go to x's. There's an x here, there's an x here, and there's an x here. So that's in common. Then I'm going to try again. Okay, I have an x here, an x here, and an x here. And that's also in common. So y, I'm going to look for y. There's y here, there's 1 here, but there's no y here, so y is not in common. So therefore, I'm going to factor greatest common factor. So that's going to be 2 times x times x. And what I will have left over in the bracket is 2 times x minus 3 times y plus 2 times y. And I will close the bracket. And of course, the last thing is to clean it up. So this will be 2x squared. This will be 4x. This one will be 3y squared. And this one will be plus 2y. And I'm done with this one. Okay, using the other method, a little bit faster method would be this way. You will look at your coefficients and find the greatest common factor, which is 2, and then you will look at your variables. First, I will look at the variable x. This one is x to the power of 3, this one is x to the power of 2, this one is x to the power of 2. Out of these 3 options, x to the power of 2 is the one with will be the greatest common factor because that's the lowest exponent with respect to x. So x to the power of 2 will go outside. Now I'm going to look at y. Well, y is here, but not here. So y is not the greatest common factor, so it's not going to be factored out. Then I will open the bracket, and again, I will take my original term and I will divide by my greatest common factor. A divided by 2 is 4. X cubed divided by x squared leaves me with x minus 6 divided by 2 is -3. X squared divided by x squared is 1. So we write times 1. And then y squared divided by, there is a 1 here too. So we'll say y plus 4 divided by 2 is 2. X squared divided by x squared is 1. And then y divided by 1 is y. All right, and now I'm going to quickly clean it up. So it's going to be 2x squared, 4x minus 3y. Oh, there should have been y squared here. Sorry, I made a mistake. There should have been y squared here because y squared divided by 1 is y squared, plus minus 3y squared plus 2y. And then I will close the bracket. And that's finished. So that's how we do this type of questions when we have to factor a polynomial, and to find a common factor here in a polynomial. All right, let's do next one. Binomial common factors. So how would you do this type of question? Okay, so approach is very similar. We will be looking at the greatest common factor for this expression. And again, hopefully you recognize that I have 2 terms here. And what I'm seeing is that the greatest common factor over here will be actually this part. It's in common to both terms. So what I'm going to do, I am going to factor it out. So bracket a minus b close the bracket. And then I'll open the bracket, and I know that my original expression had two terms, so there was a minus here in between these two terms, and I will just see what I have to write here. Well, this original term divided by a minus b will just leave me with 2x. And this original term divided by a minus b will leave me with this. And this is it. And now this is in a factor form. All right, let's try another example. Again, this is a good time to pause your video, try it on your own, and then restart to compare your answer. Okay, so one more time, this question, I'm going to do this question two different ways, a little bit longer way and a shorter way, just to kind of demonstrate the thought process. All right, so again, I have this expression with two terms. There's this plus that separates these two terms. And what I'm going to do is apply prime factorization to 6. So it's going to be 2 times 3 times a and times this expression. Then it's plus, and I'm going to my second term. It's going to be 2 times 2 times 3 times 1 y plus 1. Again, I'm going to locate my common factors and then find the greatest common factor, which is 2, 2, and then I have 3, and I do have a 3 here, and there is an a here, but there's no a here, but I also have a y plus 1 that isn't common for both. So this is also a common factor. All right, and then I'm going to take these factors outside. So really, it's going to be 2 times 3 times y plus 1. And then I'm going to open a bracket, and I know I'm supposed to have two terms in it. So whatever is left over here, this divided by 2, 3, and this divided by this was going to be 1. So then the only thing that is left over will be a. And over here, what's going to be left over is 2. And again, I am going to quickly clean it up. So it's going to be 6 y plus 1 times a plus 2. And now I have this polynomial, this expression in a factor form, and it's actually 3 terms here. All right, so how would you apply a shortcut? A shortcut, of course, will be done after you've practiced this a little more. You've spent more time on practicing this. Okay, so first thing would be to factor 6 and 12. So you know that the greatest factor will be 6. Then you will look for the other common factor in these two terms. So this one and this one. So we'll write y plus 1. And then you will open the bracket. You know you have two terms, and you will take the original term and divide by the greatest common factor. 6 divided by 6 is 1. A divided by, there's actually 1 here too. A divided by 1 is a, and y plus 1 divided by 1 plus 1 is 1. Okay, and in the second one, 12 divided by 6 is 2. There is y plus 1 divided by y plus 1 is 1. All right, and then quickly cleaning it up, it's 6 y plus 1, open bracket, a plus 2. Okay, and that's another way of doing this question, which could be a little bit faster. All right, so the last type of question is factoring by grouping. All right, so if you look at this expression, there are 4 terms, and then I would like to find a common factor, and I see that W is here, but there's no W here, and there's no W here. So W is not the common factor. And if you've checked all the other variables, you will see that none of these variables is present in all the terms. So therefore, I am going to try to factor it by grouping. and I will group the terms that have a common factor. So one way of doing it is I will quickly rewrite this, and I have a WC plus BC plus WD plus BD. And what I'm going to do is I'm going to group these two together and these two together. And then I am going to factor out the common factor. So over here, the common factor is C. So I'm going to factor out, and I know there are two terms, so I'll have to have two terms here too. And therefore, over here I will be left over with W, and over here I'll be left over with B. And then I go to the next one, plus, and over here the common factor is D, so I will factor it out, and I will be left over with W plus B. You can always double check by expanding and see if you get these expressions. All right, and then I'm not finished because I again see that I have two terms, and these two terms have something in common. And the thing that is in common is W plus B is in common to both. So therefore, I will factor it out as well. So therefore, I will write W plus B, then open a bracket. I know I had two terms, and then what I will be left over is with C here and a D here. And now this is the final answer. However, I decided to group these two together, and these two together is bad. I have another option. I could have factored them, grouped them a little bit differently. How about if I just factor all the terms that have a W in them? So this one together plus BC plus BD. Okay, and this one together. And again, I will go through the same process. I will factor W here first, and I will end up with C plus D. Over here, I will factor B, which is in common, and I will end up with C plus D. Then I will notice that C plus D is in common to both of these terms. So I'm going to factor it out, C plus D. And then I will be left with W plus B in this bracket. And as I can see it, these two answers are exactly the same. So it doesn't matter how you group these terms, as long as you group them with a common factor. All right, so this is equivalent because I can change the order, and the product, the answer for this multiplication does not change, right? That's the cumulative property of multiplication. All right, so one more example. This is the one that you will try on your own first. So pause the video, try it, and then restart to compare the answer. So this question, again, I am going to maybe group these two together. And then I am going to factor 2 from the first one. And I will be left with x plus y. Again, I can check it by expanding. Plus, that plus is here. And in the second one, what's in common is x in both of these terms. And we already know that the greatest common factor with respect to x will be the one that has a lower power out of these two. So it's x. And what I will have left over is x squared divided by x is x. And xy divided by x gives me y. All right, and then again, I see that I have two terms and there is in common to both. So I am going to factor it out. And then what I will be left over, again, with two terms, over here I'll have a 2 and x, and that will be my final answer. So this is how we factor by grouping. So hopefully you're now more familiar with different types of factoring. That's it. Have a good day. Bye.